Good morning students. In this video we are going to see problems in Unit 5 Acoustics. Example problem 5.1 in page number 61. Question number 1. At what temperature will the velocity of sound in air be double the velocity of sound in air at 0 degrees Celsius? We have to find out the temperature for the velocity of sound in air be double for the velocity of sound in air at 0 degrees Celsius. Velocity of sound in air at 0 degree Celsius. Solution. Let T degree Celsius be the required temperature and V1 and V2 be the velocity of sound at temperatures T1 Kelvin and T2 Kelvin respectively. That is, V1 and V2 are the velocity of sound. For V1 and V2, the temperatures are T1 Kelvin and T2 Kelvin. What is the value for T1? T1 is equal to 273 Kelvin, that is 0 degree Celsius. And T2 is equal to T degree Celsius plus 273 Kelvin. V2 by V1 is equal to square root of T2 by T1 is equal to square root of 273 plus T by 273 is equal to 2. That is, instead of T2 we have to substitute the value 273 plus T, and then instead of T1 we have to substitute 273. V2 by V1 is equal to 2. So, we have to write 2 here. Here it is given that V2 by V1 is equal to 2. 273 plus T by 273 is equal to 4. When we remove the square root, we get 273 plus T by 273 is equal to 4. Now, we have to cross multiply. 273 plus T is equal to 4 into 273. Now, we have to find out the T. So, we have to bring here the plus 273 to minus 273. So, T is equal to 273 into 4 minus 273. When we multiply 273 and 4, we get 1092 minus 273. Now, when we subtract 1092 and 273, we get 819 degrees Celsius. Now, the result temperature T is equal to 819 degrees Celsius. Solved problems, page number 67, question number 1. A sound producing a sound of frequency 90 Hz is approaching a stationary listener with a speed equal to 1 by 10 of the speed of sound. What will be the frequency heard by the listener? That is, a source produces a sound for the frequency of 90 Hz and then it approaches a stationary listener with a speed equal to 1 by 10 comparing with the speed of the sound. We have to find out the frequency heard by the listener. Given data, frequency n is equal to 90 Hz, velocity of the source Vs is equal to 1 by 10 B. We have to find frequency of the listener n dash. Formula: apparent frequency n dash is equal to V by V minus into n. Solution: when the source is moving towards the stationary listener, the expression for apparent frequency is frequency of the listener n dash is equal to V by V minus Vs into n. Here VL becomes 0 because the listener is at rest. So, the remaining terms are V by V minus Vs into n. Now, n dash is equal to V by V minus 1 by 10. Vs is equal to 1 by 10 V. Now, we have to substitute the value for Vs 1 by 10 V into n. Now, we have to cross multiply with the 10. So, it becomes 10V minus V, and then here the denominator of 10 goes to the numerator. So, it becomes 10V into n. So, the value becomes 10V by 10V minus V into n. Now, 10V by 9V into n, that is 10V minus V becomes 9V. So, 10V by 9V into n. Now, V and V get cancelled. So, the remaining term is 10 by 9 into n. Now when we divide this 10 by 9 into, substitute the value for frequency. The value for frequency is 90. So 10 by 9 into 90. When we multiply 10 and 90, we get 900 by 9 hertz. Now when we divide this, we get 100 hertz. Now what is the result? Frequency of the listener n dash is equal to 100 hertz. Question number 2. A source producing a sound of frequency 500 hertz is moving towards a listener with a velocity of 30 ms minus 1. The speed of the sound is 330 ms minus 1. What will be the frequency heard by the listener? That is, a source produces a sound for the frequency of 500 hertz. The frequency of the source is 500 hertz. And then it moves towards a listener. The source is moving towards a listener with a speed of 30 ms minus 1. The speed of the sound is 330 ms minus 1. Now we have to find out the frequency heard by the listener. Given data, frequency n is equal to 500 hertz. Velocity of the source is 30 ms minus 1 and then speed of sound is 330 ms minus 1. We have to find frequency heard by the listener n dash. Formula: apparent frequency n dash is equal to V by V minus Vs into n. When the source is moving towards the stationary listener, the expression for apparent frequency is n dash is equal to V by V minus Vs into n. When the source is moving towards the listener, the apparent frequency is V by V minus Vs into n. Now we can substitute the value for V and Vs. V is 330 by 330 minus 30 into 500. 500 is the frequency. Now we subtract 330 and then 30. We get the value 330 by 300 into 500. Now that value becomes 33 by 30 into 500. When we divide 33 and 30, we get 1.1 into 500. When we multiply 1.1 and 500, we get the value n dash is equal to 550 hertz. What is n dash? Apparent frequency. That is frequency heard by the listener. So the result, frequency heard by the listener is equal to 550 hertz. Question number 3. A source of sound is moving with a velocity of 50 ms minus 1 towards a stationary listener. The listener measures the frequency of the source as 1000 hertz. What will be the apparent frequency of the source when it is moving away from the listener after crossing him? The velocity of the source is given as 50 ms minus 1. The source is moving towards the listener. Now the listener measures the frequency of the source as 1000 hertz. That is, n dash is 1000 hertz. And we have to find out the apparent frequency for the source is moving away from the listener. Understand the question? The first one is the source is moving towards the listener. So when the source is moving towards the listener, the velocity is given and then apparent frequency also given. Now we have to find out the apparent frequency for the source is moving away from the listener. So given data, velocity of the source Vs is equal to 50 ms minus 1. Frequency of the source n dash is equal to 1000 hertz. Velocity of sound in the medium V is equal to 330 ms minus 1. We have to find apparent frequency n dash of the source moving away from the listener. Formula: apparent frequency n dash of the source moving away from the listener is equal to V by V plus Vs into n. Suppose if the source is moving towards the listener, then what is the formula? V by V minus Vs. If the source is moving away from the listener, then the formula is V by V plus Vs into n. Solution: when the source is moving towards the listener, the expression for apparent frequency is, here first we have to find out the source is moving towards the listener. And after that we have to find out the source is moving away from the listener. N dash is equal to V by V minus Vs into N. What is N dash? 1000 is equal to 330 by 330 minus 50 into N. 1000 is equal to 330 by, when we subtract 330 and 50 we get 280 into N. Now what is N? We have to find out the N value. So we have to cross multiply this 1000 into 280 by 330. When we multiply 1000 and 280 we get 2,80,000 by 330. Now when we divide this we get 848.48 Hertz. Now N is equal to 28,000 by 33. When we divide this we get 848.48 Hertz. The actual frequency of the sound N is 848.48. Now then the source is moving away from the listener, then the expression for apparent frequency is N dash is equal to V by V plus Vs into N. Now what is V? 330 by, what is V? 330 again plus, and Vs is 50 into frequency is 848.48. Now 330 by 380, when we add 330 plus 50 we get 380 into 848.48. Now when we divide 330 and 380 we get 0.86842 into 848.48. Now when we multiply these two values, that is 0.86842 and then 848.48, we get 736.837 Hertz. Now when we round off this we get 736.84 Hertz. Result: the apparent frequency of the source when the source is moving away from the listener is 736.84 Hertz. Problem 4. A source and listener are both moving towards each other with a speed V by 10, where V is the speed of sound. Source also moving and listener also moving with a speed of V by 10. Here V is the speed of sound, that is 1 by 10 of the speed of the sound. Now here the frequency is of the source is given as F. We have to find out the frequency heard by the listener. Given data, velocity of the source Vs is equal to V by 10 and then velocity of the listener V by 10, because both are moving towards each other with the same speed. So V by 10 and V by 10. Now the frequency of the source N is equal to F. We have to find frequency heard by the listener. Formula: frequency heard by the listener N dash is equal to V plus VL by V minus Vs into N. When source and listener are moving towards each other, the apparent frequency is N dash is equal to V plus VL by V minus Vs into N. Here VL is the velocity of the listener, Vs is the velocity of the source, and V is the velocity of the speed. Now when we substitute the value, N dash is equal to V plus, instead of VL we have to write V by 10 by V minus, instead of Vs we have to write V by 10 into N. Now we have to cross multiply with the 10. So we get 10V plus V by 10 and then 10V minus V by 10. Now we have to write this in a multiplication form. When we write this in a multiplication form, 10V plus V by 10 into 10 by 10V minus V. The denominator becomes the reciprocal. Now 10 and 10 get cancelled. So we get 10V plus V is equal to 11V and 10V minus V becomes 9V into F. What is F? It is the frequency. Instead of N we have to substitute frequency F. It is given in the question itself. The frequency is F. Now V and V get cancelled. So the remaining term is 11 by 9 F. When we divide 11 by 9 we get 1.22 F. So the result is the frequency heard by the listener N dash is equal to 1.22 F. Fifth problem. At what speed should a source of sound move away from a stationary observer so that observer finds the apparent frequency equal to half of the original frequency. We have to find out the speed when the source is moving away from the observer. And then here the observer finds the apparent frequency, that is n dash. That n dash is the half of the original frequency. Apparent frequency n dash is equal to n by 2. N is the original frequency. The apparent frequency is half of the original frequency. So we can write n by 2. We have to find velocity of the source Vs. Formula: apparent frequency n dash is equal to V by V plus Vs into n. When the source is moving away from the listener, the expression for apparent frequency is n dash is equal to V by V plus Vs into n. Instead of n dash, we write n by 2 and then V by V plus Vs into n. Now this n will comes to the opposite side. So n by 2n, that is here the n is in multiplication. Now when it comes to the opposite side becomes division. So n by 2n is equal to V by V plus S. Now n and n get cancelled. We get 1 by 2 is equal to V by V plus Vs. Now we can cross multiply this. V plus Vs is equal to 2V. We can find out Vs. So Vs is equal to 2V minus V. 2V minus V is equal to V. When we subtract 2V and V, we get V. So the velocity of the source is equal to velocity of the speed. What is V? It is the velocity of the speed. So the velocity of the source is equal to velocity of the speed. Vs is equal to V. Now 6th Roman, answer very briefly, page number 71, question number 4. What will be the frequency sound having 0.20 meter as its wavelength when it travels with a speed of 331 ms minus 1? We have to find out the frequency. The sound, that is the distance of the sound, the wavelength is given as 0.20 meter. And then the speed is given as 331 ms minus 1. So given data, wavelength lambda is equal to 0.20 meter and then speed v is equal to 331 ms minus 1. We have to find out frequency n. The formula relating velocity, wavelength and frequency is v is equal to n lambda. From this we can derive the frequency. So frequency n is equal to v by lambda. Now solution, we can substitute the value for v and lambda. What is the value for v? 331 ms minus 1. And then for lambda 0.2 meter. Now meter and meter get cancelled. So the remaining term is s minus 1. This s minus 1, that is the reciprocal of the time, is the frequency. So it is hertz. Now to remove the decimal, multiply with the 10 to the numerator and denominator. So the value becomes 3310 by 2. When we divide that value, we get frequency n is equal to 1655 hertz. Now what is the result? Frequency n is equal to 1655 hertz. 7th Roman, answer briefly, page number 71 in your book. Question number 3. Air temperature in the Rajasthan desert can reach 46 degrees Celsius. That is, the temperature in Rajasthan desert is 46 degrees Celsius. We have to find out the velocity of sound for that particular temperature. The velocity VO is equal to 331 ms minus 1. The temperature in Rajasthan desert is 46 degrees Celsius. For that temperature, we have to find out the velocity of sound. So VO is equal to 331 ms minus 1. Velocity of sound VO is equal to 331 ms minus 1. Air temperature T is equal to 46 degrees Celsius. Velocity of sound in air at that temperature Vt is equal to VO plus 0.61 T ms minus 1. This formula is given in your book. Now we can substitute the value for VO. For VO is 331 plus 0.61 into temperature is 46 ms minus 1. Now we can multiply 0.61 and then 46. We get 28.06 ms minus 1. Now we can add 331 and 28.06. We get 359.06 ms minus 1. So the result velocity of sound in air at 46 degrees Celsius is equal to 359.06 ms minus 1. Thank you, students.